Hi guys, and welcome to the Learn Extra revision session on Euclidean Geometry. In this section we'll be looking at similarity of triangles. Firstly, we're going to start by just giving you a quick checklist of things you need to remember for the exams. So let's have a look at that. Guys, you need to remember to learn the proofs of the following theorems. A line drawn parallel to one side of a triangle divides the other two sides proportionately. And you need to also know the proof of the theorem that equiangular triangles are similar. Now, you know in geometry that whenever you make a statement, you need to give a reason. The reasoning needs to make sense, guys. So I just want to give you a reminder of what the theorem says and what your statement should be in the exam, the abbreviation that you should be using. So remember to use correct reasoning when using theorems to state your case. So first let's look at what the theorem statement says, and then we'll have a look at what the acceptable reasoning is. The first one, the line segment joining the midpoints of two sides of a triangle is parallel to the third side and equal to half the length of the third side of the triangle. The acceptable reasoning when you use that theorem statement is, we call that the midpoint theorem. So you won't rewrite the entire statement out. It's simply appropriate and acceptable to write that reason as the midpoint theorem. The next one, the line drawn from the midpoint of one side of a triangle parallel to another side bisects the third side. That reason, that's your theorem statement, your acceptable reason would be line through midpoint parallel to second side. The next theorem statement, a line drawn parallel to one side of a triangle divides the other two sides proportionately. As your acceptable statement, you can either use line parallel to one side of a triangle, or you can call it the proportion theorem, proportion abbreviated as prop, or you could simply name the parallel lines. If two triangles are equiangular, this is now the next theorem statement, then the corresponding sides are in proportion and consequently the triangles are similar. As your acceptable reasoning, you can either say similar triangles, which is abbreviated using the sign for similarity, or you can simply state equiangular triangles. Now the converse of that, if the corresponding sides of two triangles are proportional, then the triangles are equiangular and consequently the triangles are similar. There you can simply state sides of a triangle in proportion, again abbreviating proportion to PROP, prop. Now guys, you need to remember that in geometry, all the theorems you've learned from previous grades can be integrated into your grade 12 question. So you can't just learn the section in isolation. You need to remember all of the previous geometry as it may be integrated into the questions in grade 12. Also, all the circle geometry, that will also be incorporated when we look at similar triangles, as you will see later on when we do a couple of questions. The one exam tip that I want to give you guys, and it is very, very important that you remember this, is that if you have attempted to answer a question more than once, and it often happens, you get a better idea as you're going through the question, then make sure you cross out the answer that you do not want marked. Otherwise, guys, all that's going to happen is that your first answer is going to be marked and the following working out that you really wanted to be marked is going to be ignored. So make sure that you cross out the answers that you don't want the examiner to mark. All right. So having said that and keeping that all in mind, hopefully you all have that. You've all got it. Well, good. Keep it. Let's move on to the first exam type question. All right. So question 1 says, in the triangle below, or in the diagram below, triangle PQR has S on PQ and T on PR such that ST is parallel to QR. That is drawn on your diagram. they tell you that PT is equal to 4 units, SQ is equal to 9 units, TR is 6 units, and PS is 2x minus 10 units. They then ask you to calculate the value of PS. All right, so now that you've looked at the diagram, you've got to decide what theorem are you going to use that's going to be relevant to this question. And you can see that in this triangle, you are given that one side, ST, is drawn parallel to the third side of the triangle. So straight away in your mind, you should start thinking about the theorems that you know of that can help you to answer this question. And the first one that should come to mind is the proportional theorem, or the proportionate theorem, all right? So, because ST is parallel to QR, we can set this out as follows. And this is question 1. We can say PS over SQ is equal to PT over TR. And here you can simply write your reason as proportion theorem. Or if you want to, you can name the parallel sides. So going to the diagram, we're saying that PS over SQ is equal to PT over TR, and that's a straightforward application of the proportion theorem. All right, we know that PS is 2x minus 10, so we can put that down. We know that SQ is 9. PT was given as 4 units, and TR was given as 6 units. And now you simply have a linear equation which you can use cross multiplication in order to solve. All right, so if I cross multiply, I will get 6 times 2x minus 10 is equal to 4 times 9. Timesing into my bracket, I'll get 12x minus 60 is equal to 36. Take the 60 over to the other side, so you get 12x is equal to 60 plus 36. And you will get from there 12x is equal to 96. Dividing both sides by 12, you'll get that x is equal to 8. All right. Now, guys, the worst thing you can do here is leave that as your answer, because you're cheating yourself out of marks. Because remember, the question didn't ask you to solve for x. They said calculate the value of PS. And remember, PS was 2x minus 10. So therefore, we need to substitute that value for x back into the expression for PS. So PS was 2x minus 10. I know that x is 8, so therefore I'll substitute the 8 in place of x, and I get 16 minus 10, so therefore PS is equal to 6 units. All right, so that's just a straightforward application of your proportion theorem. Guys, there's no reason for you to get this wrong. You understand the application. You will generally be asked a straightforward question like this, which is easy to follow on just by using the reasoning that you already know and what the theorem tells you. All right, with that said, I think it's time for you guys to digest all of that information, and when we come back, we'll look at a few more exam type questions. Hi guys, welcome back. It's time to do a few more exam type questions. I hope you're all ready and rearing to go. Let's get started. So this is question 2. You are given a diagram triangle PQR, and you are told that B lies on PR such that 2 times of PB is equal to BR. So what that means, 2BP is equal to BR. So for example, if PB was X, then using your ratios, BR would be 2x. All right. The other way you can write this, guys, is you can say dividing both sides by 2 and by BR, you can rewrite this as PB over BR is equal to 1 over 2. And then you can see your ratio clearly. So PB over BR is 1:2. Okay. They tell you that A lies on PQ such that the ratio PA over PQ is 3:8. So that's 3 and PQ is 8. They tell you that BC is drawn parallel to AR. All right, we've marked down all the given information. We've just highlighted all the information that they gave you on the diagram. Now let's have a look at the first question. So the first question for 2 marks, write down the value of the area of triangle PRA over the area of triangle QRA. So we're looking at PRA, that area of that triangle, over the area of triangle QRA. All right, so let's put this little one, the bigger one, in a different color. What you will notice is that those 2 triangles will have the same altitude, the same height. So therefore, when you're working out the area of triangle PRA over triangle QRA, it's simply going to be the ratio PA over AQ, because your altitudes are going to cancel out because they are exactly the same, right? So therefore, this is going to be equal to the ratio PA over QA. Now, remember, they told you that PA over PQ is 3:8. Now, that was your ratio. But what it means is that entire length, that entire ratio there is going to be 8. So therefore, if PA is 3, AQ would have to be 5. All right. So therefore, PA over AQ is simply going to be equal to 3/5. And the reason here we said that the area of the one triangle over the other can simply be written as PA over QA. That was because of equal altitudes. All right. Okay, so guys, now that we've looked at the first part of this question where we used the fact that we were given the ratio and we could therefore find the area of the one triangle over the other, let's have a look at how they incorporate the parallel lines into a proportion theorem question. So question 2.2 asks you to work out the ratio of BD over BQ. Okay, so on your diagram they want the ratio of BD, which is that one, over BQ, which is the entire length. Okay, you've got your parallel lines BC parallel to AR, and since AD is part of that same straight line AR, it would then imply that AD is also parallel to BC. Okay, now if you look at your diagram, you need the ratio BD over BQ, but you've got to relate that to something else, because as it stands, we cannot work out the ratio directly. We've got to relate it to something else, and that something else will help us to work out the ratio we need. So from my parallel lines, using the proportion theorem, I can state, and this is question 3.2, sorry, this is question 2.2, we can state that BD over BQ is equal to CA over CQ. And that's simply a fact from the theorem that we've applied. All right, so BD over BQ is equal to CA over CQ. So on your diagram, this is what we're saying. That's CA and that's CQ. So in other words, if you can get the ratio CA over CQ, then BD over BQ is going to be exactly the same. Right, now let's use the other given information. Remember they told you that PB is to BR is the ratio 1:2. So therefore that over that was given as a ratio 1:2. Okay. They also initially told you that PA over PQ was 3:8. Okay. Now guys, what we're going to do is using the parallel lines BC and AR, because we know that PB is to BR is 1:2, that means that this little section here, and we're going to put it in a different color, PC over CA must also be in the ratio of 1:2. And the reason for that is because CB is parallel to AR. Okay, so therefore we know PC over CA must also be in the ratio 1:2. But we know that PA is 3. So therefore PC must be, if we say I always find it easier to work with Y's and X's when we're dealing with proportion questions and when we have to use ratios. So I'm going to say let PC equal to Y. Now if PC is Y, that means using my ratio that PC over CA is 1:2, that would then imply that CA is 2Y. All right, but we know that the whole thing in relation to the side PQ is 3:8, so therefore PA must be 3Y. So therefore PQ is 8Y. And if PQ is 8Y and PA is 3Y, that means that AQ is 5Y. All right? Why do we need to make all these statements? Because remember, none of this should be taken as given or common knowledge. Anything that's not explicitly stated needs to be shown by you, and you need to give the right reasons for making those statements. So when we write the proof down, you will see we incorporate everything that I'm showing you on the diagram. Now, the reason I needed to show again that AQ was 5Y and that CA was 2Y is then I can use the whole length CQ as 5Y plus 2Y, 7Y. Okay, and we need that length in order to answer this question. All right, let's write it all down now. Okay, so we've said that BD over BQ is equal to CA over CQ because of the proportion theorem. We can also state that PB over BR is equal to 1/2, and that was given. You were given that 2 times PB was equal to BR. Therefore, we can say PC over CA is equal to 1/2. And the reason for that, either state your parallel lines or you can say proportion theorem. And then we can make the statement about letting PC equal Y. So if PC is equal to Y, then we know that AC is going to be equal to 2Y, and that's because of your proportion theorem, and it was stated that PB over BR is 1:2. And therefore, we know that CQ will be equal to 7Y. And remember, the reason CQ is equal to 7Y is because CQ was AC plus AQ. So therefore, we can state that CQ is equal to 7y. So therefore, CA over CQ will be equal to 2 over 7 as your ratio. All right? It's obviously going to be 2y over 7y. The y's cancel, and you get 2 over 7 as the ratio. But we didn't want just CA over CQ. We wanted BD over BQ, and that would be exactly the same ratio. So therefore, BD over BQ will also be equal to 2 over 7. All right. Okay, guys, so that was just an example of how you can use different triangles to help you to get to the ratio that you are actually asked for in the question. Okay, now it's time for us to move on to the next question, and this is question 3. All right. So we'll have a look at the diagram just now, but we're told that PQ is a common tangent to the two circles that are drawn. S is the center of the larger circle, and QS is the diameter of the smaller circle. T and R are points on the larger circle, and TSR is a straight line. TQ cuts the smaller circle at M, and RP is perpendicular to QP. So all of that information is given in the diagram as you see. All right. Now what I like to do is I like to mark down information that we can see on the diagram without even looking at the questions. You know, just very, very quickly, just to give yourself an idea of where you're heading with this question and what theorems you will need to be able to apply. So let's look at the diagram quickly before we look at the questions. All right. They told you that PQ is a common tangent. So straight away I'm already thinking, well, hey, there's an X there. So therefore, when I've got tan chord theorem, I can say that that X is going to be the same as T. So I'm not marking, I'm not putting anything down. I'm just sort of already thinking of where I'm going with this, right? They told you RP is perpendicular to PQ, so we know that's 90 degrees. They also told you that S was the center of the larger circle. So if S is the center of the large circle, that means that TR would be your diameter. So if that's the diameter, that means that this angle Q must be 90 degrees because of angle in the semicircle, right? Okay, so we're already thinking of those kind of things. Similarly, they also told you that SQ was the diameter of the little circle. So therefore, that means that M2 must be 90 degrees. Okay. We've marked down quite a bit of information. Let's see if this can assist us now in answering the questions. This is now question 3.1. First part, they say prove that, or prove giving reasons that Tm is equal to Mq. So on your diagram, they're asking you to show that Tm is equal to Mq. Now remember, you were given that S is the center of the larger circle. Okay? TQ is a chord of the larger circle. And we saw just by drawing all our given information on the diagram, we've already shown that M2 is 90 degrees. Well, we've shown in our heads, we already have an idea of where we're going. So if I've got line from center perpendicular to a chord, immediately I'm thinking of the theorem that tells me that that line is going to bisect the chord. So there we go. We already have the proof or the reasoning for question 3.1. Let's write this down. Okay, so this is 3.1. We know that angle M is going to be 90 degrees. Okay, and if you go back up, let me show you angle M, M2 that is. All right, so angle M2 is going to be 90 degrees. And the reason for that is angle in semicircle. So therefore, that's going to imply that SM is perpendicular to TQ. And if SM is perpendicular to TQ, and we knew, looking back at your diagram, we knew that S was the center of the circle, and since SM is perpendicular to TQ, we know line from center perpendicular to chord bisects the chord, so therefore we can say TM is equal to MQ. All right, and your reason there is line from center. All right, and guys, what you would notice is just by looking at the diagram and putting down a lot of the information, we already have an idea of where this question is going, what possible things they could ask us. Okay, let's have a look at part 2, 3.2. Here they want you to show that QR bisects angle PRS. So QR, being that line there, they want you to show that it bisects angle PRS. So in other words, they're asking you to show that R1 is equal to R2. Now we can see that angle in triangle PRQ, we can work out that R2 is 90 minus x using angles of a triangle, because they told you that angle P is 90. You were given that angle RQP is x, so therefore using angles of a triangle, R2 must be 90 minus x. So therefore it means that you need to show that R1 is also 90 minus x in order to show that this angle is bisected. Let's look at the diagram. We know, using tan chord theorem, that angle RQP is going to be equal to angle T because of tan chord theorem. We also know that angle Q, 1 plus 2, is going to be 90 degrees, and the reason for that is because TR is the diameter of the bigger circle. So therefore, looking in triangle TRQ, we know that T is x, Q1 and 2 is 90, so therefore R1 must be 90 minus x using sum of angles of a triangle. Let's now write down this proof. It's only worth 2 marks, so we need minimum amount of working out. So this is 3.2. All right, so we can say angle R2 is equal to 90 minus x, and the reason for that, sum of angles of triangle QRP. We know that angle PQR is equal to angle T, which is then equal to x, and the reason for that was tan chord. All right. Therefore, we can say that angle R1 is going to be equal to 90 minus x, and we need to just state here that angle Q was equal to 90 degrees, and that was because of angle in semicircle. All right. Therefore, we can say that angle R1 is 90 minus x, and the reason for that was sum of angles in triangle QTR, and therefore we can say QR bisects angle PRS, because we know that angle R1 we've just shown is equal to angle R2. Okay, so the reasoning just follows from what we've shown on the diagram. All right. Okay, let's move on to question 3.3. Here you are asked to show that triangle PQR is similar to triangle QTR. Now guys, remember the way to show that triangles are similar in this specific type of case where you aren't given any ratios, You show that triangles are similar by proving they are equiangular. All right? Equiangular triangles are similar. Right? So I need to show that all of the angles in triangle PQR are equal to all of the angles in QTR. Really what you need to do is to show that two of the angles are equal to two of the other angles, and then the last one is just by sum of the angles, it's your remaining angle. Okay, so let's just mark down the triangles that we're interested in, and I'm going to take off all of the other drawings that we've made on this diagram. Okay, so we're looking at triangle PQR. Okay, and you can see that RQ is a common side, and now we've got triangle RQT. Okay, so those are the two triangles you're looking at. Remember, we also showed that angle T was equal to X. We showed that R1 was 90 minus X, and we showed that R2 was 90 minus X. So just by looking at your diagram, and we've also shown that that's 90, you can see that those triangles are equiangular, therefore they must be similar. Let's write our proof down. All right, and this is 3.2. When you start your similarity, you state the triangles that you're working in. So in triangle PQR and triangle QTR, we need to now list which angles are equal and the reasons they are equal. We know that angle PQR, and this was all shown previously, angle PQR is equal to angle T is equal to X. You can rewrite the reason of tan chord, or you can say previously shown. I'm just going to rewrite the reason, tan chord theorem. All right. And then we can say angle R1 is equal to R2, and that was just proved. So therefore, the last two must be equal to each other because it's the remaining angle in the triangle. So therefore, we know angle P is equal to angle TQR, and that's because it's the remaining angle. But we also saw that they are both equal to 90 degrees. Okay? Since all the angles are the same, we can now make our statement. Therefore, triangle PQR must be similar to triangle QTR, and the reason there is angle, angle, angle. Okay. Now generally, if they've asked you to prove that two triangles are similar, they're going to test you on some of the ratios within the triangle, and that's exactly what happens in question 3.4. They ask you to show that RQ squared is equal to 2 times SQ times RP. Now, if you look at those sides, RQ is the common side between the two triangles we've just proved similar. SQ, all right, SQ doesn't look like it belongs to the triangles that we just proved similar, but we're going to show you that it does. And RP is also one of the sides of the triangles we've just proved similar. Now, let's have a look at SQ. Remember, right in the beginning, they've told you that S was the center of the larger circle. So therefore, that means that SQ, SR, and ST are all radii. So therefore, they can be used interchangeably. Okay, so that's a little trick that we can often do in an exam, is we can say, prove SQ is equal to, and use that as one of your ratios. But you need to realize that because it's equal to another side, we could actually, in fact, be referring to one of the sides in your similar triangle. So you need to relate it to a side in one of your similar triangles. So therefore, SQ is the same length as SR. SR is the same length as ST. So therefore, TR is twice SQ. Okay, let's write down the proof for this one. This is now 3.4. All right. So from the similar triangles, which we've just proved above there, I can say that PR over RQ, or QR, is equal to RQ over TR. And that's because we just proved that triangle PQR is similar to triangle QTR. All right. Now if we cross multiply, we'll see that RQ squared is equal to PR, which is the same as RP, times TR. Now, if you look at what they've asked you to prove, as we've already discussed, TR is not in the question. That's not what they've asked you. They've asked you for 2 times SQ, but I've already shown you that 2 times SQ is actually equal to TR. We've just now need to write this down as a logical reasoning in our proof. Okay? So therefore, we're going to now say TR is equal to 2 times SR, right, which is equal to 2 times SQ. And the reason for this was SR was equal to SQ, and these were radii. All right. So therefore, that means I can replace TR with 2 times SQ. So therefore, RQ squared we can rewrite as 2SQ times PR. All right, which is exactly what they asked you to show. All right. Okay, guys, I hope that this has cleared up some of the issues you might have with proving ratios in similar triangles and using the proportionate sides once you've proved that 2 triangles are equiangular. I think it's a good time for us to take a break now before we come back and do another exam question. Welcome back, guys. We're looking at revision of similar triangles, and this is to assist you with your paper 2 work. All right, we're on to question number 4. Let's have a look at question 4. In the figure, AGD is a semicircle. AC is a tangent to the semicircle at A, and EG produced intersects AC at B. AD intersects BE in F, and you're told that AG is equal to GD and E1 is equal to X. All of the information that they've actually given you and stated in the question is drawn in your diagram. All right. What I do want to point out is the fact that they told you AC is a tangent to the semicircle. That straight away tells us, so if AC is your tangent to the semicircle with AE being your diameter, that means that this angle A is going to be 90 degrees. Now the reason for that is, remember, you know that the radius is always perpendicular to the tangent. So therefore it follows to reason that your diameter, which is twice your radius, will also be perpendicular to the tangent. So therefore I can make that statement that angle A is 90 degrees. It is something we're going to need to state later on, and it is something we will need to use in this proof. Okay, now let's quickly look at the diagram and let's get an idea of what theorems we're going to use. They told you that E1 is equal to X. I can see that GDAE is a cyclic quad, right? So therefore straight away I'm going to start thinking about things like angles in the same segment. All right. And the other two that I've left out there as well. Okay, angles in the same segment. We also have been given that GD is equal to GA. Okay, so those were equal chords. So I'm also going to need to think, what does equal chords tell me? And there's a theorem that states that equal chords subtend equal angles, and that's something we definitely will need when we look at question 4.1, which states, write down with reasons 4 other angles each equal to X, We've also got a ratio to prove in question 4.2, and then in 4.3 we've got to show that B1 is equal to D1. Remember, geometry questions are always cascaded. They're never done in isolation. You're generally going to use a previous question to answer the following questions. All right, let's get started with 4.1, and I'll show you this on the diagram, and we will write it down as we go as well. So we're given that E1 is x. They want 4 other angles each equal to x. All right, so straight away, the thing that shouts out at me or to me is that A2 is going to be equal to angle E1, which is going to be equal to x, and the reason for that is angles in the same segment. All right, so A2 is equal to E1, angles in the same segment. We were then told that GD is equal to GA, and this is when we have to use the theorem which states that equal chords subtend equal angles. So if you follow through, look at the angle that GD subtends. We see that GD is going to subtend angle E1, and then using GA, we see that that subtends angle E2. So therefore E1 is going to be equal to E2, which is going to be x, and our reason there is equal chords subtend equal angles. So angle E2 is equal to x, which is equal to E1, and its equal chords GD and AG. Okay. Now moving on to our third angle, we've got that E2 is equal to x. So therefore, if E2 is equal to x, using angles in the same segment, I can then say that D2 is also going to be x because of angles in the same segment. GD, EA is the cyclic quad that we are talking about. So therefore, point 3, we can say that D2 is equal to x, and that's angles in the same segment. And what's even better here is if we relate D2 to E2. So D2 was actually equal to E2, and that's the angle in the same segment that we are referring to. Okay. And then the last one, we have that D2 is x, and we know that A2 is x and E2 is equal to x. So we just need one more in order to complete question 4.1. Remember, they told you that AC was a tangent to this circle. So therefore, using tan chord theorem, it means that A3 is going to be equal to E2, and the reason for that is tan chord theorem. So therefore, I can say A3 is equal to E2 is equal to x, and the reason for that is tan chord theorem. All right, so there we go. We have our 4 angles, each equal to x. 8 marks, nice, 8 marks. If we understand our theorems, easy application of the theorem. All right, let's move on to 4.2. Okay, so question 4.2 says, prove that BE times DE is equal to AE times FE. Now let's have a look at which sides these are in the triangles that we've been given. So we have BE, we have DE, AE, and FE. Okay, so the triangles that's indicating that we're going to be working with is triangle FDE and triangle BEA. Those are the two triangles we're going to be working with, and we're going to need to try and split this ratio up to see it a little bit more clearly if we really need to. If we haven't shown this on the diagram, split the ratios up and see that those definitely are the two triangles that you're going to be working with. So I can rewrite this ratio as BE over AE is equal to FE over DE. So all I've done is I've simply divided the left-hand side by DE and the right-hand side by DE, and then I've divided both sides by AE. So I can see that split up, this is a proportion of two sides in one triangle, and this is another ratio that shows us another two sides in the other triangle that we are interested in. Okay, so guys, this really should show you without a doubt which triangles you need to prove are similar. Okay, so we're going to say in triangle BEA and triangle FED. Remember, to prove that they're similar, we need to state at least two angles that are equal to each other. I know that angle E1 is equal to E2. We've already shown this. We really don't need to prove it in any way. We simply state here that it was proved. Okay. We know that angle A was equal to 90 degrees. And the reason for that was the diameter. As I said to you, the radius is perpendicular to the tangent, so therefore the diameter is also perpendicular to the tangent. Angle A is equal to 90, and angle D3 is also equal to 90 because of angles in the semicircle. Now let me just show you that one. If we go back up, angle D3, that's the angle we're talking about there. And we know that AE is the diameter of the circle, so therefore angle in the semicircle means that D3 is equal to 90. So what I've just showed is that angle A is equal to angle D3. All right, and therefore just by using sum of angles in a triangle, it stands to reason, the last one, that angle B1 will be equal to angle F2 because it's the remaining angle. Okay, now that we have our three angles, we can say therefore triangle BEA is in fact similar to triangle FED, and the reason for that is angle, angle, angle. Okay, now that we have these two triangles similar, remember we're not done yet. We still need to state the ratio that they asked us to prove, right? So from the similarity, I can say, I know that that's going to give me BE over EA is equal to FE over ED. And then simply by cross multiplying, I will get the ratio that they asked us to prove, BE times ED is equal to FE times AE, which is the same as EA. Okay, all right guys, so I just showed you in this question that when they give you a ratio, don't let it flummox you. You simply break it up into its respective triangles. Once you know which triangles to prove similar, from the similarity you can deduce that the sides are in proportion. All right, time to do the last part of this question, and this is 4.3. Here we are asked to prove for 4 marks that B1 is equal to D1. So B1 being the angle here, we've got to prove that B1 is equal to D1. Okay, we have got a lot of information that we have already shown and that we've already proved. Okay, I'm going to remind you of that information in order to help us to answer this question 4.3. All right. Remember, we've just shown using angles in a semicircle that D3 was 90. We've previously shown that D2 was equal to x. Okay. We also know that EA was perpendicular to AC because the diameter is perpendicular to the tangent. And we know that E2 is equal to x, which was also previously shown. So therefore, using triangle ABE, it is possible to work out angle B1. And then, using angles on a straight line, it's possible to work out angle D1. And should those be the same, then we can state that angle B1 is equal to D1. So let's see if we can show that these two are the same. Okay, we're going to start with B1. So I'm going to say angle B1 plus angle E2 plus angle A is equal to 180 degrees, and the reason for that is sum of angles of triangle ABE. Okay, therefore B1 is going to be 180 degrees minus the sum of E2 and A2. So it's going to be 180 minus, and remember we showed that E2 was equal to x and A was equal to 90, so it's 180 minus 90 plus x. So therefore we get that B1 is equal to 90 minus x. Okay, so now that B1 is 90 minus x, we simply need to show that D1 is the same thing. So we can say here D1 plus angle D2 plus angle D3 is equal to 180 degrees, and the reason for that is sum of angles on a straight line. All right, so therefore I can say that D1 is going to be equal to 180 minus the sum of D2 and D3, and if you look at your diagram, D2 was x, D3 was 90, so therefore the sum of them is going to be 90 plus x, so therefore angle D1 is going to be equal to 180 minus 90 is 90 times the minus n, so I get 90 minus x. So therefore we can state that B1 is equal to angle D1 because they're both equal to 90 minus x. All right. Okay, guys, and that is it for this lesson on similarity. I hope that it has helped you quite a bit in your exam revision, and good luck for paper 2. Triangles, which is abbreviated using the sign for similarity, or you can simply state equiangular triangles. Now the converse of that, if the corresponding sides of two triangles are proportional, then the triangles are equiangular and consequently the triangles are similar. There you can simply state sides of a triangle in proportion, again abbreviating proportion to PROP, prop. Now guys, you need to remember that in geometry, all the theorems you've learned from previous grades can be integrated into your grade 12 question. So you can't just learn this section in isolation. You need to remember all of the previous geometry as it may be integrated into the questions in grade 12. Also, all the circle geometry, that will also be incorporated when we look at similar triangles, as you will see later on when we do a couple of questions. The one exam tip that I want to give you guys, and it is very, very important that you remember this, is that if you have attempted to answer a question more than once, and it often happens, you get a better idea as you're going through the question, then make sure you cross out the answer that you do not want marked. Otherwise, guys, all that's going to happen is that your first answer is going to be marked and the following work. Hi guys, and welcome to the Learn Extra revision session on Euclidean Geometry. In this section, we'll be looking at similarity of triangles. Firstly, we're going to start by just giving you a quick checklist of things you need to remember for the exams. So let's have a look at that. Guys, you need to remember to learn the proofs of the following theorems. A line drawn parallel to one side of a triangle divides the other two sides proportionately. And you need to also know the proof of the theorem that equiangular triangles are similar. Now, you know in geometry that whenever you make a statement, you need to give a reason. The reasoning needs to make sense, guys. So I just want to give you a reminder of what the theorem says and what your statement should be in the exam, the abbreviation that you should be using. So remember to use correct reasoning when using theorems to state your case. So first, let's look at what the theorem statement says, and then we'll have a look at what the acceptable reasoning is. The first one, the line segment joining the midpoints of two sides of a triangle is parallel. Should come to mind is the proportional theorem or the proportionate theorem, all right? So, because ST is parallel to QR, we can set this out as follows. And this is question 1. We can say PS over SQ is equal to PT over TR. And here you can simply write your reason as proportion theorem. Or if you want to, you can name the parallel sides. So going to the diagram, we're saying that PS over SQ is equal to PT over TR, and that's a straightforward application of the proportion theorem. All right, we know that PS is 2x minus 10, so we can put that down. We know that SQ is 9. PT was given as 4 units, and TR was given as 6 units. And now you simply have a linear equation which you can use cross multiplication in order to solve. All right, so if I cross multiply, I will get 6 times 2x minus 10. Working out that you really want it to be marked is going to be ignored. So make sure that you cross out the answers that you don't want the examiner to mark. All right. So having said that and keeping that all in mind, hopefully you all have that. You've all got it. Well, good. Keep it. Let's move on to the first exam type question. All right. So question 1 says, in the triangle below, or in the diagram below, triangle PQR has S on PQ and T on PR such that ST is parallel to QR. That is drawn on your diagram. They tell you that PT is equal to 4 units, SQ is equal to 9 units, TR is 6 units, and PS is 2x minus 10 units. They then ask you to calculate the value of PS. All right, so now that you've looked at the diagram, you've got to decide what theorem are you going to use that's going to be relevant to this question. And you can see that in this triangle, you are given that one side, ST, is drawn parallel to the third side of the triangle. So straight away in your mind, you should start thinking about the theorems that you know of that can help you to answer this question. And the first one that L to the third side and equal to half the length of the third side of the triangle. The acceptable reasoning when you use that theorem statement is, we call that the midpoint theorem. So you won't rewrite the entire statement out. It's simply appropriate and acceptable to write that reason as the midpoint theorem. The next one, the line drawn from the midpoint of one side of a triangle parallel to another side bisects the third side. That reason, that's your theorem statement, your acceptable reason would be line through midpoint parallel to second side. The next theorem statement, a line drawn parallel to one side of a triangle divides the other two sides proportionately. As your acceptable statement, you can either use line parallel to one side of a triangle, or you can call it the proportion theorem, proportion abbreviated as prop, or you could simply name the parallel lines. If two triangles are equiangular, this is now the next theorem statement, then the corresponding sides are in proportion and consequently the triangles are similar. As your acceptable reasoning, you can either say similar